In this example, we want to find the difference quotient of f. The difference quotient is defined by this expression here, f of x plus h minus f of x over h. H is not equal to 0. Division by 0 is undefined. And we want to find the difference quotient for this function here, f of x equals square root of x minus 20. We have a hint that says to rationalize the numerator, and rationalizing the numerator will be part of our simplification process once we find the difference quotient. So we want to find the difference quotient for this function, f of x equals square root of x minus 20, and our difference quotient, f of x plus h minus f of x over h, is square root of x plus h minus 20. So that's this first part of the difference quotient. Now minus our function f of x, so minus square root of x minus 20 over h. So this is the difference quotient, but we want to simplify it more. And that's where the hint comes in, to rationalize the numerator. Now to rationalize the numerator means that we don't want a radical in the numerator. So to get rid of the radical in the numerator, we're going to use a strategy of multiplying by the conjugate. So the conjugate, we're going to multiply by the conjugate. And the conjugate is the expression that we see in the numerator, except with a plus sign instead of the minus sign. So it has the opposite sign in between those two radicals. So we're going to multiply by square root of x plus h minus 20 plus square root of x minus 20. And we're going to do that on both the numerator and the denominator. And the reason why we're doing it on both the numerator and denominator is because when we put it in both the numerator and denominator, we're multiplying by a form of 1. And multiplying by 1 doesn't change the expression. So we're going to multiply by the conjugate. And in the denominator, we want to leave this expression in the factored form. So in the denominator, I'm going to leave this as h times that conjugate of x plus h minus 20 plus square root of x minus 20. However, in the numerator, I don't want to leave it in factored form. I want to multiply it out. And what you're going to see when we multiply it out is that some of the terms cancel out and some of the terms cause the radical to go away, which is our goal. Our goal is to rationalize the numerator, get rid of the radical in the numerator. So when we multiply, we'll multiply these two terms together first. Those are the first two terms. And when you multiply those together, so let's write it out. We have square root of x plus h minus 20 times square root of x plus h minus 20. When we multiply those two together, because they have the same radical and the same thing under the radicals end up canceling each other out. We'll take a look at that in just a few moments on the next step. So then we're going to multiply the outside two. That's going to give me a plus square root of x plus h minus 20 times the square root of x minus 20. Then we'll multiply the inside two together. It's going to give me a minus this time, a minus square root of x minus 20 times the square root of x plus h minus 20. Okay, I'm going to adjust here a little bit. And I hope that's within screen. Let's zoom out a little bit to make sure it is. And then we multiply the last two terms together. We're going to have minus square root of x minus 20 times square root of x minus 20. So that's what we get when we multiply it out. We're going to simplify some more. We're going to still leave that denominator in factored form. So we're going to leave that as h times square root of x plus h minus 20 plus square root of x minus 20. So let's focus on multiplying these two together. So when we multiply those two together, when you multiply radicals together, you multiply what's underneath them. And what's underneath them is the same, x plus h minus 20 times x plus h minus 20. So we can write that as x plus h minus 20 squared, and then underneath the square root. Now then let's focus on these two terms. If we look at this term and this term, this first one is positive and the second one is negative, and they have the same factors. So that means that they are like terms, but they're also opposites of each other. And we know that opposites cancel each other out. So those two terms just go away. They zero out. And then when we multiply these last two together, once again, they both have radicals, and they have the same expression underneath the radicals. We're going to multiply those expressions together. X minus 20 times x minus 20 is x minus 20 squared, and that's still underneath the radical with a minus sign. And what we know is that square roots and squares are opposite operations. So they cancel each other out. So we're going to get x plus h minus 20. So we're getting that because the square root and the square are opposite operations and they cancel. And then on the next term, the square root and the square cancel each other out. And we're left with that x minus 20. But be careful, this minus sign applies to this whole expression. So we need to put minus in parentheses here to make sure that minus sign applies to all of those terms. And once again, we're leaving the denominator the same in factored form. And you'll see in just a moment why we did that. So we have h times square root of x plus h minus 20 plus square root of x minus 20. So now that the radicals are gone in the numerator, we're going to use the distributive property to get rid of these parentheses. That's x plus h minus 20 minus x plus 20. We're leaving that denominator alone again. Square root of x plus h minus 20 plus square root of x minus 20. And in the numerator, we have some like terms. We have a positive x and a negative x. So not only are they like terms, but they're opposites and they cancel each other out. We have some more like terms, a negative 20 and a positive 20. Also opposites, they cancel each other out or zero out. And so all we have left in the numerator is an h. In the denominator, we have h times square root of x plus h minus 20 plus square root of x minus 20. And we have a common factor in the numerator and denominator that cancels, this common factor of h. will cancel out. And this is our final expression. We have 1 left in the numerator, and in the denominator we have square root of x plus h minus 20 plus square root of x minus 20. And this is our difference quotient for the function f of x equals square root of x minus 20. Thank you for checking out my videos. Have a great day.